Newbiehack.com. We provide a great deal of information on our products and spend a lot of time doing this so you don't have to. In this video, I'm going to introduce the 4x4 Keypad. It's a new product on the Newbiehack website, and I'm also going to show you how it works and give you an example in code. This particular type of keypad has a standard header that you'd use with a normal mail header like this. It has an adhesive back, so you can essentially place it anywhere. No screws needed. And the way it works is all of the columns are tied to all the rows. So even though you have 16 keys here, you only have 8 connections. And the connections reference the rows and the columns. So there's 4 connections for the rows and then there's 4 connections for the columns. The arrangement of the keys are in a telephone type of configuration, where you have the 1, 2, 3 up the top, and then it goes down to the 0 in the middle and the bottom. You have an asterisk, a pound, and you have A, B, C, and D on the right-hand side. At the connections, you have 1, 2, 3, and 4 rows, and then you have 4 columns. When a key is pressed, for instance, the number 1 key, that is on row 1 and column 1. So that means that this is the number 1 for the row, and then you have the other 3 rows, and then you have the number 1 for the column. And this would be connected when the number 1 key is pressed. So when the number 1 key is pressed, these two become connected. Let's draw the array. And these are the rows, and these are the columns. And this is how it will be connected to a microcontroller. You can also represent this as indexed by 0, so let's do that also. So you have 8 pins, which also corresponds to the number of ports you have, or the number of pins on a port. So you can actually use this to save into a variable when you plug it into a port. So when the number 1 is pressed, we're going to set the microcontroller up so that will show up the 2 digits that would be in that particular arrangement would be shown up as a 0 or a low value. So let's say that number 1 pressed would be represented by 0 starts from here, so it would be 0, 1, 2, 3, 4, 5, 6, 7. This would be a binary number. So the 0 position would be 0, then it would be a 1, and a 1, and a 1. And then at the 4, because this is 4 and it's on that column, you'd have a 0, and a 1, 1, and a 1. So this would be the binary number that would represent the number 1 key press. The number, let's say the number 9, would be the 2nd position and the 6th position. So we would be, the 2 would have a 0, and then the 3 would have a 1, 4, 6. So this would be the binary number for 9. To test the circuit, I've taken the keypad and I've plugged in a bunch of wires, one after the other, and I've just plugged it into one of the ports, and I'm using port D. So this part of the connection, which is the 0 digit, 0 place, would be at port D, pin 0. And then I went all the way down to 6, and then the 7 is on the other side. I also included an LED on pin B0, so I can use it for testing. And what I intend to do is, when I press a button here, I have 16 digits. So what I'm going to do is, if I press number 1, it'll blink 1 time. If I press the 16th, it'll blink 16 times. So let's go ahead and see what this program would look like. We'll create a new project using ML Studio. I'm going to call it Keypad Quick Test. And I have the Atmega 644 plugged in at the moment. Okay, let's write some pseudocode so we can understand what we need to do. We're going to use a polling method rather than an interrupt method. The interrupt method requires that we add a few more components to the breadboard, like diodes, but we're not going to, I don't want to go through all of that. And the polling method doesn't really take much resources anyway. What I'd like to do is try to write a program so it will call a scanning of the keypad And if there is nothing pressed, if it just reads a bunch of 8 digits of ones, then it'll just return right back to the loop. So really it's only wasting one instruction or looking at one instruction to test to see if the keypad is being pressed. The first thing we need to do is initialize everything. So we're going to initialize the LED, initialize the keypad, data direction, and port settings. We need to create a function. I'm going to go ahead and rough out the function. We're not going to be returning anything at the moment. We may later, but we just wanted to blink some LEDs. And you might want to just use the return for as a car data type, so you can actually return the actual character when it scans the keypad, but I'm not going to do that. Keypad scan. And we're not going to be putting anything in this function either. We don't need to pass anything into the function, since we're just going to look at the state of the pins on the port D. And we're going to have the program blink the number of times that represents the digit pressed, the key pressed. Before we do anything, we want to make sure that we press something. Is the keypad pressed? Most of this is pretty easy. The only mystery is really figuring out how to scan the keypad. So let's go ahead and do the low-hanging fruit. Let's initialize the LED, and this is on port B. You know what? I'm going to create definitions here for the LED ports and things like that. Start with the keypad. BDRD, this is going to be on port D. And then we're going to access the port value, which is going to be the pin D. Well, that will give us the value of what is in the port. This is the control, and this is the data direction. So let's go ahead and do the LED. And that will be GDRB and LED, the port. That's port B. And I do this because it makes the program, whenever you're using this, there's a couple reasons. And the first reason is because it's more readable. The program, when we start using these names that we've created, we'll see that throughout the program. We'll know exactly what the program is doing. The second reason is because if you just use the DDRD throughout the program, or the port D, you may have this in many places. So it's easier just to change it in the beginning. If you change the connections from port D to port A, for instance, you'd only have to change this. So let's go ahead and take care of some of this down here. Let's initialize the LED, and I'm just going to make it equal to output for the pin 0. I could have also written it like this. And then we're going to initialize well, I'm going to keep the LED off as a default, and that just means I don't have to actually put in anything for the port. So let's go ahead and initialize the keypad. Direction register. Alright, this is where it becomes a little bit tricky. We're going to need to scan only one portion of the keypad at a time. We can scan all of the rows, or we can scan all of the columns. So half of the data direction is going to be input. And I'm going to start with the last, the last 4 digits, which is the first in this scenario. The 0, 1, 2, and 3 will be output, and then 4, 5, 6, and 7 will be input. Now the port, we're going to pull the inputs high. The first 4 will be 1s, and then the last 4 will be 0s. And just to give a little bit of an explanation to this, when an input is pressed, let's say this particular digit, the number 4, it will be connected to one of these digits, which is output at a 0, which is 0 volts or ground. So this will be brought down low, or it will turn into a 0, for instance. So that is how we determine which button is pressed for an individual row, since these are the columns. These are the columns. So we'll know which column is pressed in the beginning. And here we forgot to put some pseudocode here, but we're just going to call the key scan, the keypad scan. And it's just going to keep calling it. We'll have other code for whatever application. And then as it's doing that, it'll quickly do a keypad scan. If there's anything pressed, it'll do the scan. If there's nothing pressed right in the beginning, that is the keypad pressed, it'll just go right out of this and come straight back to the regular code that we have in the loop. So when we do the keypad scan, let's go ahead and make it so if we go into the keypad scan, if there's nothing pressed, it'll immediately escape out and come back to the standard program flow. This is vitally important because you don't want the keypad scan taking any time more than it needs to when it comes to inputting the keypads and scanning it. So let's take care of the needless one, which is the port value. We'll call it if the port value keypad is equal to 0B and then just ones, 1, 2, 3, 4, 5, 6, 7, 8. We're just going to return. That's it. So when it goes into the keypad scan, if it finds that nothing was clicked because they're all ones, actually when it's right here, it will be zeros here, won't it? Yeah, because these aren't pulled. If these aren't pulled low, any of the columns aren't pulled low, because these are in a low state in the beginning, then we'll return. Now let's get to the scanning of the keypad. If this is true, then let's put a little delay in here, so we know that a delay of 50 milliseconds. This is generally the common debouncing delay. I'm just doing this because if there's nothing hit, then it's just going to return out of here, and this won't even be read. So it's pretty safe to actually put this delay in here, because if there is a 0 here somewhere, we want to make sure that we wait just a tiny bit of time, which is a fraction of a second, for the mechanical bouncing of the signal to become stable, and then we can go ahead and scan the keypad. And the way we do this, we just store the state of the port, or the keypad port value, into another variable. So let's actually make that variable, and we're going to make it a variable that is, it can be internal. It should be actually in here. So I'm going to make it an 8-bit integer, an unsigned integer. There we go. Where is it? There we go. That one right there. And we'll call it key press code, and that will equal, initially it'll equal the key port value. Now you're probably wondering, how are we going to get the row information? Well, we're going to reverse the data directions and the port state, or the port control. So we'll take the keypad direction register, and we will make it equal to the opposite of what we had down here. So we want not the columns to be input, we want the rows to be input, and that's over here. So let's go ahead and make the columns now output and the rows now input. Let's take the control register, and just like before, we're going to take the output and make them 0, so they're 0 volts or are grounded. And then the last ones, which is the input, we're going to pull them high with a resistor, which means they're in a high state. If you don't do this, the ones here or the ones over here, then you have what is called a tri-state, or a state that actually will receive interference like crazy. You'll find that I've done this many times as a mistake, just accidentally not putting it into a high state. And if I just put my hand over the input device, it could cause the LED to turn on, and it'll make the values jump all over the place. Okay, the next line is something I actually read on a lot of forums that we are required to do after doing some kind of changes to a register for the general purpose I/O pin, and that is to give it just a tiny time delay, so this can actually be registered. And we've used this before in the LED or LCD programming. So this creates a time delay of one instruction, so this can be processed. Now what we want to do is, now we have this in the correct state, we're going to receive the port value for the other 4 digits, these 4 digits now. So we can take the key press code and add those 4 digits to these positions. And we use the OR operator for that. So we're essentially keeping what's there, the initial keypad value, which was key port value, which was the last 4 digits, or the columns. Now we're going to add the other 4, because the other ones are going to be 0 anyway. So we'll take the value here and just ORing it to the existing, what's already in there in this variable. Let me show that to you in an example. If when we get into this area for scanning the keypad, we may have a number like 1, 1, 0, 1, which is the columns, and then we'll have 0, 0, 0, 0. That will be at this particular position. But when we get to this position here, once we've read the last 4 digits, this will be 0 because we are bringing those low right there. And then this will have something in it, maybe. Well, it would have to if it's a good button press. So now we're going to do this calculation because we're ORing it with this instruction. This will be a 1 because a 1 or a 0 is 1, 1 or a 0 is 1, 0 or a 0 is 0, 1 or a 0 is 1, and then the rest in the similar fashion, 1 and 1. So we have our columns and we have our rows. The next part you can do in probably 1,000 different ways. We could take this number here and do some calculations that will give us a number or code that we want. We can do some shifting of the numbers. We could actually do that before we even get here and find out exactly what position relates to what number. I'm going to do it a different way because I want to show you exactly what's happening. And I'm going to make an if statement for each button press or each key press. And there'll be 16 variations, and each variation will have what I think that particular code will be, and it will create another variable or assign a variable a number for the blink duration. So if the number 1 key was pressed, the one in the top left, it will blink 1 time. If the key on the bottom right, which is the 16th key, it'll blink 16 times. So we will have some way of knowing that what we're doing here is actually working. So let's start with the first one. We need to have another variable. We'll call that blink duration. And we'll have it equal 0 in the beginning, just creating a default. So if it doesn't equal any of the possibilities, 1 through 16, it will be equal to 0, and we can have it return out of this as soon as that happens. We don't have to go through the blink instructions. So let's start off with the if. Yeah, I don't need that. Okay, so we would want to test the key press code, and if this equals to 0B, 1, 1, 1, 1, 1, 1, 1, 1. Let's see. First row would be 0 here, and the first column would be a 0 here, because this is the 0th digit, and this is the 4th, which is the first column, as we noted on the sheet with our grid of numbers. And then we'll have the blink duration equal to 1. We're going to do this about 4 times for the rows, or for the columns actually. So these are going to stay the same. These will stay the same. We're going to have to change this number here. So this would be the next row, or no, the next column. This will be the next column. Make this a 1, and then the last column. So you'll see the zeros going in a diagonal fashion because this would be, if it is a 1, then the first column and the first row would show a 0. And let's put a 2 here because it's going over another column. 3 and then 4. This is going to stay kind of the same with the next 4. The only thing that's going to change is the row. So we're going to put 1s in each of these and change this to a 0. So we're now going to the next column, or the next row. We started out with the first row, and now we're going to the next row. We have to change our numbers, 5, 6, 7, 8. Since we're starting back at the first column, now we're going to go to the next row. And by the way, to do a selection in a more of a rectangular fashion, use the Alt key, and then just left click your mouse and drag. And let's change this, 5 to 8, 9, 10, 11, 12. So let's do that to the next 4. So this will be the last row. Okay, you could easily do this in a nested for loop, because we're looking at the first row, second row, third row, fourth row, but nested within each of them is the first, second, third, and fourth column. But in this particular fashion, you can see exactly what's going on here with the numbers associated, the blink duration numbers, or the key number associated with the actual binary number, and how it changes. Now let's have another condition to see if anything was pressed, because if this shows up as nothing is pressed after the debounce, that means that it was just an anomaly, and it's not really a key press. So let's go ahead and test for that. We can do this if it's less than since this would represent no keys being pressed, because we've already created our variable. And if these zeros do not exist, if these aren't shown in this variable, then that means that nothing was pressed. But if it was less than that, then something was pressed, because this would be the highest number you can have. You could also use blink duration. If blink duration is equal to 0, then nothing was pressed as well, because then these wouldn't have been. Oh, look at that! I didn't change this. Then these wouldn't be assigned. So I'm going to keep it like this, and we'll put a for loop inside, and we'll use an I for an integer. And I is pretty common. If I is less than blink duration, and then let's increment I. So we're going to have this going, we're going to have it counting up to the blink duration limit, which is assigned here. And let's create a delay so we can see the blink. I'll use a 50. I'll use 100. 50 is a little bit short. Oh, I don't want that. It's the LED port. And we'll toggle the LED port at pin B0. And we'll do that again so it turns it off. So we're going to blink it on, then blink it off. We don't actually need the delay. No, we do need the delay actually, because we need it to delay while it's on so we can see it on. And we need a delay here because we need to see it off for a certain amount of time as well while it's going through the loop. We don't need to, this is the pseudocode we created. Let's bring that up here. We don't need to reset any of these variables because they're local. When we get out of this function, all the variables in here that were created locally, which is the blink duration and the pressed code, those will be erased or used as another part of memory, or considered memory that can be used. I think this should take care of it. I'm going to try and build it and see if it builds. Crossing my fingers. Nothing. Look at that. I did not. Well, let me build it again. I'm going to show you what it said. Undefined reference to delay milliseconds. And this is because we didn't create an include to include the delay header file. Yeah, util delay. So now this should work. Let's go ahead and try building it again. Okay, it built. Now let's try to program it and see if it actually works. We need to change this to release. We'll use the 644. I didn't build it in the release, so let's build it again. Let's do another. Yeah, there we go. Now it's successfully programmed. Let's check to see if it works. Okay, let's see. Press the 1. Looks like it does not work, which is not very surprising because we did a lot of code all at once. And let's take a look at the code and see if we can figure what we did. Okay, now we're back to the code. One thing I'm not sure of, and I think it could be in this location here, is I'm actually writing over what state this port could be in, and I don't want to do that. I would rather do it in more of a different type of fashion, like ORing it or toggling it. So to get the inverse of this, to get the inverse of this, we can do toggling just like we're toggling an LED. But we would have to put all ones here. Just like we have a 1 in pin B0, we're toggling it using a 1. So to toggle the entire port, we would just put a bunch of 1s there. So let's do that to this as well. I'm not sure if this will work, but I'll give it a try. So let's try it again. Build. Okay, let's see if it works. Nope, still doesn't work. Alright, let's take a look at our code again. This is where a simulator will come in handy. Alright, let's take a third look at the program. I don't think I got this one wrong. I think maybe I'm not giving it enough time to change these registers. And I did read in another forum that you have to have at least one of these. So I'm going to go ahead and put 2 and see what happens. It feels like trial and error, but sometimes this is what you have to do to get these things to work. Okay, let's try it. Okay, we got an LED blink when I pressed 1. When I pressed 2, I got 2, 3, 4. Let's try 16. I'm going to pretend that's 16, or assume that is 16. Let's try 4. Yeah, that looks like 4. Well, actually 5. This would be 8. Yeah, that looks like 8. Okay, so that is how to use the keypad. You can get these on the Newbiehack website. And now you know how to program these in detail and how to make it work. If you are following along with these experiments or producing successful projects on your own, helped by these tutorials, please let me know using the Contact Us page on the newbiehack.com website. I would like to feature these on the website to benefit and motivate others to join this creative field. Thank you.